Hello everyone, I am A.B.M. Salman Rahman from Suncheon National University, Suncheon, South Korea, Department of Information and Communication Technology, and I am Integrated Doctoral Fellow. As everyone knows, energy is one of the most important factors in our daily life, and we are not able to consider one single step without energy. So, we have to be very careful about utilize our daily energy, and it will be more profitable for our future life. Today, I am going to present a study on smart factory manufacturing products characteristics based on energy consumption. Objectives: energy modeling and analysis is now a very important sector for a smart factory. For making some profitable things, we need to analyze our energy to get good results. Energy modeling and analysis is now a time-intensive process in smart factories. Smart factory energy consumption analysis and forecasting are important for optimizing energy utilization rate and generating profits in the industrial sectors. Energy analysis and forecasting are becoming increasingly important to an industrial factory. As a consequence, now is the ideal time to work as a supportive technological hand to reduce energy uses and provide some profitable results for smart factories. As I told earlier, industrial energy consumption analysis is important to make some profitable things for industrial authorities. But analyzing uses of energy and making accurate estimates of industrial energy consumption is a difficult task. As a result, this research analyzes energy consumption for each month to determine difference between uses of energy and energy demand. It creates a relationship curve among energy consumption, energy demand, and various manufacturing products. For energy consumption forecasting, we use time series model. This study forecasted energy consumption by ARIMA and seasonal ARIMA and compared the actual data curve with predictive data curve to improve the energy utilization rate. The performance evaluation result for ARIMA and seasonal ARIMA based on RMSE, root mean square error. For ARIMA, it is 8.70, and for seasonal ARIMA, we get result 10.90. Finally, we will find out the most important product for the smart factory to improve the energy utilization rate for getting profitable things for smart factory. Introduction. We are not able to consider one single step without energy. In today's world, so much energy is consuming for both economic growth and population expansion. So, we must have to consider how we might minimize our energy uses. Rapid economic growth has increased global electric power and energy consumption. Meanwhile, electricity is among the most significant drivers of economic development and also essential in our daily life. Manufacturing, mining, agriculture, and construction industries use electricity to process, produce, or assemble items in their building or equipments. Overall, the industrial sector's energy usage is more than 1/3 of the nation's electricity. As a result, forecasting electrical energy consumption has become more essential for a country or area. A smart factory is an IoT idea that proposes a production process as completely automated and intelligent network of technologies that allows facilities, equipment, and logistical chain to operate without the need for human interaction. Furthermore, a smart factory is a location where all of these things occur due to data interchange between all elements in the production technologies chain, not only between production tools and machines. Life has been made more accessible because of the achievements of the third scientific and technological revolution. Industrial output is a vital part of the economy for both government and financial industry. Our study deals with analyzing uses of energy consumption for every month with every hour data to find out the difference or relation between uses of energy consumption and demand of energy consumption. We also make a relationship curve among of uses of energy, demand of energy, and different types of material weight for manufacturing product. Our study forecasted energy consumption using ARIMA and seasonal ARIMA and compared the actual data curve with predicted data curves to improve the energy utilization rate. Finally, we determined the most effective product for the smart factory to enhance the energy utilization rate and obtain the profitable things for the smart factory. Methodology. I have already told before we use time series model for forecasting industrial energy consumption data and production data. Here we will know about what is time series model, what is ARIMA, and what is seasonal ARIMA. Time series model. Time series model is a grouping of well-defined information focuses measured at the reliable time intervals over where. The time series analysis helps us to understand the underlying forces leading to a particular trend in time series data points and help us to forecast and monitor the data points by fitting appropriate models. The full form is ARIMA is autoregressive integrated moving average. It is a model used in statistics and econometrics to measure events that happen over a period of time. The model is used to understand past data or predict future data in a series. Seasonal autoregressive integrated moving average model is a one-step different from an ARIMA model based on the concept of seasonal trends. In many time series data, frequent seasonal effects come to play. Take for example the average temperature measured in location with 4 seasons. Data description. In our study we have two types of data and datasets are collected from Daewoo Steel Factory. One set data from Daewoo Steel Factory energy consumption data, and this dataset is collected by Smart Energy Meter. And another dataset is production data. From energy consumption data, we know about 24 hours uses of energy, demand of energy, lagging reactive power, current, leading reactive power of current, predicting percentage of leading power and the percentage of lagging powers. And from the production dataset, we know about manufacturing product, product name, material length, material weight, product item, and also a lot of information. From manufacturing data, we know about there are three types of products are manufactured in Daewoo Steel Factory, and the products are sheet, scalp, and seam. Load type and its timing. This table represents different types of load and their timing concerning each month. The table information all collected from KEPCO. From the table we can see different type of load time. There three load time is there. Load type is there. Off-peak load, mid load, and peak load. And for three load type, energy charge also different. For off-peak load, energy charge is lowest, and for peak load, energy charge is high, and it's more than 3 times compared with off-peak load. And they are divided in 4 seasons also: summer, spring, fall, and winter. In summer, energy charge is high for a peak load compared with spring, fall, and winter. Result and discussion. In result and discussion part, we will told about the result of analyzing per month energy data. Analyzing energy data with materials will show the result about analyzing energy data with material weight and manufacturing products, and will show ARIMA and SARIMA forecasting, and also will also show the comparison between forecasting data and actual data, and then we'll go for conclusion. Analyzing per month energy data. To determine the per hour uses of energy consumption for 12 months, we analyze 2017 energy consumption data. We analyze total energy consumption per hour for every month from energy consumption data of the year 2017 to find out every hour uses of energy and determine the time period of high amount of energy consumption uses and time period of less amount of energy consumption uses. From this figure shows 24-hour uses of energy of working days energy consumption of every month in 2017. In the figure, the x-axis shows the time in hours and y-axis shows the total uses of energy in kilowatt. From the figure, we can see that the every month from 8 am to 10 pm uses of energy is so high, and we can also see that after 11 pm to till 8 am energy consumption is low. Based on figure, we can easily say that steel factory working hours start from morning 10 am and work finish hour is night 10 pm. Analyzing energy data with material weight and manufacturing product. As we told before, three types of products are manufactured in Daewoo Steel Factory. Here we analyze different types of material weight for manufacturing product with total uses of energy for the number of working days. From figure 1 shows the different types of material weight of manufacturing product with per day total uses of energy for number of working days. The figure x-axis shows the number of working days and y-axis shows the material weight in kg for 2017. The blue line shows daily energy uses for working days, while the red dot shows the daily material weight for sheet production. Green dot shows for material weight of scalp, and purple shows the material weight of seong. From the figure, we can say that the energy consumption also increase when the density of material increase. It means when production are high, uses of energy consumption are also high. From figure 2, we can see that the everyday total material weight of manufacturing product with total uses and demands of energy consumption for the number of working days. The x-axis shows the number of working days in the figure and y-axis shows the material weight in kg. From the figure, we can see that the blue line shows the uses of energy for the number of working day. The red line shows for maximum demand of energy, and green line shows the total weight of material for number of working days. From the figure, we can easily find out that when production is increased, uses of energy also increase, and production low means uses of energy also going down. ARIMA and seasonal ARIMA forecasting. ARIMA and seasonal ARIMA are a sequence of well-defined data points measured at consistent time intervals. Over a period of time, ARIMA and seasonal ARIMA helps us to understand the underlying forces leading to a particular trend in data points and help us in forecasting and monitoring the data points. This diagram shows for forecasting energy consumption of January 2018 based on 2017 energy data by using ARIMA. The x-axis has number of month in 2017 and y-axis has the energy consumption in kilowatt. The black color lines refers the actual energy consumption. In the blue line refers to predicted energy consumption, and the gray line refers to the maximum and minimum range of the prediction. This plot is based on 2017 past data to predict the January 2018 energy consumption data. This figure shows the forecasted energy data based on past 2017 year to predict January month 2018 by using seasonal ARIMA. The x-axis has the number of month of 2017 and y-axis has the energy consumption in kilowatt. The black color refers the actual energy consumption. The blue line refers to predict energy consumption, and the gray line refers the maximum and minimum range of estimation prediction. This plot based on the past 2017 year data to predict 2018 January data. The past data and predicted data are more connectivity because both have more fluctuation. Comparison between actual energy data with ARIMA forecasted energy data, January 2018. From the figure we can see the comparison between actual and predicted energy uses statistics. The x-axis represents the number of days between January 1 to January 31, 2018, while y-axis refers the energy used in kilowatt. The blue line represents ARIMA model predictive data. The pink line represents actual uses of energy. The green dotted line represents the maximum and lower range of 80% confidence intervals. The gray dotted line represents the top and lower range of 95% confidence interval. So based on the predictive data, we suggest taking the upper range of 95% confident interval and lower range of 80% confident intervals. Comparison between actual energy data with seasonal ARIMA forecasted energy data. From the figure we can see the comparison of original energy consumption data and forecasted energy consumption data. The x-axis has the number of days from 1 to January 31, 2018, and y-axis has energy consumption in kilowatt. The blue line refers to predicted data using seasonal ARIMA model, and the pink line refers the actual energy consumption data. The green dotted line refers to the upper and lower range of 80% confident intervals. The gray dotted lines refers to upper and lower range of 95% confidence intervals. So, based on predicted data, we suggested taking the upper range of 95% confident intervals and the lower range of 85% confident intervals. This table shows the forecasting models performance for Deo Steel Factory dataset for ARIMA and seasonal ARIMA. From the table we can find out the performance evaluation result for ARIMA by mean error, root mean square error and mean absolute error. For seasonal ARIMA also. For ARIMA we get mean error 0.59, root mean square error 8.70 and mean absolute error 6.72. For seasonal ARIMA we find out mean error 0.24, seasonal ARIMA root mean square error 10.90 and mean absolute error 8.79. From the table we can say that ARIMA gave better result than seasonal ARIMA. Variable importance for the Deo Steel Factory. From the figure we can easily explain that scalp is the most essential product for Deo Steel Factory, and for producing scalp this factory use maximum energy. Deo Steel Factory energy consumption table for the year 2017. This table shows the using percentage of energy for each manufacturing product, and from table we find out that scalp using 49% of energy of total uses of energy. Sheet is using 39.70, and Seong is used 5.62% only. From the table we can easily tell that scalp is using maximum energy from the total energy. Conclusion. This study focuses on industrial energy uses analysis and forecasting to enhance energy utilization rates and make steel plants more profitable. This study shows the 1-month forecasting curve for steel factories using the ARIMA and seasonal ARIMA time series model, and finds the comparison curve between the actual and forecasting values. Table 3 shows that most energy is used for scalp production at 49.82%, sheet production at 39.70%, and Seong production at 5.62%. In the year 2017, this smart factory produced the most scalp with maximum amount of electricity. In order to make energy a lucrative item for the business, we propose to operate 2 shifts in the factory, one during the day and one during the night, such as during peak hours and off-peak hours, so that the firm's energy cost will be reduced. As well as we have discovered, scalp production is closely connected with energy uses, so allow authorities to manufacture scalp during the night shift. That's all from me. Thank you very much for watching my presentation with patience, and see you next.